Okay, so today we're talking about the division properties of exponents, divide monomials using properties of exponents, and simplify expressions containing negative and zero exponents. So to divide monomials, we can use the principles of reducing fractions to find quotients of monomials like 10 to the second power over 10 to the first power. In the following examples, look for a pattern in the exponents. So basically, if you have 2 to the 7th power, you could say 2 times 2 7 times, and 2 times 2 4 times. You can simplify. 2 over 2 is 1 over 1. Same thing for 4 of those. Then that leaves you with 2 times 2 times 2, or 2 to the third power. Works the same way with variables, okay? And so basically what this would be is 2, the numerator exponent, minus the denominator exponent would be 2 to the power of 3, okay? Same thing with here. You would have t, the numerator exponent, minus the denominator exponent, would give you t. So to divide two powers with the same base, you subtract the exponents. So let's take a look. We have g to the third, h to the fifth power, over g, h to the second power. So they separated these down by same bases. And then you just basically subtract, again, the exponent in the numerator by the exponent in the denominator. And remember, when there's no exponent, there's really a 1 there. So 3 minus 1 is 2. 5 minus 2 is 3. G squared times h cubed. Okay? All right, so let's take a look at this. We could separate these down as a to the fourth over a times b to the seventh over b squared. And that would give me a, 4 minus 1, times b, 7 minus 2, or a to the third, b to the fifth power. Okay? All right, you try this one and then come back and see how you did. All right, let's see how you did. So if I group these together, I would end up with m with the exponent 5 minus 4 to give me 1, so that's just m. There's only one n in the numerator, so that's n. And then we have p over p, which would be 1 minus 1 in the exponents, which would be 0. And anything to the 0 power is 1, so that leaves me with mn. Okay? And we're going to talk about that 0 exponent in just a moment. All right, so we can use the product of powers property to find the powers of quotients for monomials. In the following example, look for the pattern in the exponents. So if we have 3/4 cubed, that would be the same as 3/4 times 3/4 times 3/4. So if we look at just the numerator, we would be adding the power of 1, power of 1, and power of 1 to get 3 cubed. In the denominator, we would add the powers up and we get 4 cubed. Okay? Works the same way, of course, as variables. So basically what we're doing is we're distributing that exponent to the numerator and to the denominator. Okay? So, for example, we have this problem here. We would have 3p cubed over 7 squared. Well, we distribute that exponent to the numerator and the denominator. Okay? And then 3p to the third we have as a grouping with the exponent on the outside, so we distribute that to the 3 and to the p to the third, and we end up with 3 squared, p to the third power squared, over 7 squared. Now we just simply solve what we have here. 3 squared would be 9, p to the third power squared would be 3 times 2, which would be 6, so p to the sixth, and 7 squared would be 49. Okay? So let's look at that again. We have this right here. So the first thing that I'm going to do is I'm going to distribute. So I'm going to have 2a to the third, b to the fifth, and that's all going to be cubed. And I'm going to have 3b squared, and that's going to be cubed. And now when I look at the numerator, I'm going to take the 3 that's in the exponent and distribute that to the 2, to the 3, a to the third power, and to b to the fifth power. Okay, we're going to distribute that to all of these. So I would have 2 cubed, then I would have a to the third power is going to be cubed, And I'm going to have b to the 5th power is going to be cubed. And then I'm going to do the same thing in the denominator. 3 is going to be cubed, and then b squared is going to be cubed. So 2 cubed would be 8, right? Because 2 times 2 is 4, times 2 is 8. And then a to the 3rd cubed is going to be a to the 9th. And then b to the 5th power cubed is going to be b to the power of 15. And then 3 cubed is 27. And then b squared to the 3rd power would be b to the 6th power. And then finally, we can get the final answer would be 8 a to the 9th power. And then we have this right here with the same bases. So 15 minus 6 is going to be b to the 9th power all over 27. And that would be my answer. Okay? All right, you try this one, then come back and see how you did. All right, let's see how you did. So these are the steps I would have taken, and you should have ended up with 36w to the 10th power and 40 over 49 p to the 12th power r to the 6th power. Okay? All right. So now all this is basically stating is when you look for the exponent of 0, you're going to end up with 1. So for example, if I have 3 to the 5th power over 3 to the 5th power, 5 minus 5 is 0. So I get 3 to the 0 power. Now let's look at that out as 3 times 3 times 3 times 3 times 3, 5 threes, in the numerator and the denominator. When you simplify that down, you end up with 1 over 1, which is 1. So therefore, any 3 to the 0 power is the same thing as 1. Okay? So anything to the 0 power, anything, will be 1. So let's look at that. We have A. We have this one right here. We have all this stuff inside of the brackets, or the parentheses, right? But it doesn't matter because we have this exponent of 0. Anything with the exponent of 0 is 1. So the answer to that is simply just 1. Now in the B, we have x to the 5th power, y to the 0 power over x to the 3rd power. Well, y to the 0 power is just 1. So that gives me x to the 5th power over x to the 3rd power. 5 minus 3 would give me x squared. So x, 5 minus 3 is going to give me x squared. Okay? All right, let's look at, let's talk about negative exponents. So to investigate the meaning of negative exponent, we can simplify expressions like c squared over c to the 5th power using two methods. So first, we can simply just subtract them. So c squared over c to the 5th, that would be 2 minus 5, which would give me c to the negative 3rd exponent. And let's break it all down. C times c over c times c times c times c times c. And once we simplify these down, we get 1 over c to the 3rd. So c to the negative 3rd is the same as or equal to 1 over c to the positive 3rd exponent. Okay? So what that tells us is for any non-zero number, a, and any integer n, or a to the negative nth power, is the reciprocal of a to the positive nth power. Also, the reciprocal of a to the negative n power is a to the n power. So in other words, if I had 2 to the negative 4th n power, its reciprocal would be 1 over 2 to the 4th power, or 1/16. And just like that, the opposite of that, if I have 1 over, let's say, j to the negative 4th power, the reciprocal would be j to the positive 4th power. So you're just kind of flipping them over, okay? Remember reciprocal. So an expression is considered simplified when it contains only positive exponents. Each base appears exactly once, and there is no powers of powers, and all fractions are in simplest form. So let's take a look. we have n to the negative fifth power, p to the fourth power, all over r to the negative second power. So we could take each one of these separately, because if we multiply these all together, we're going to get that answer. So we're just kind of breaking the problem up just to visualize it. So n to the negative fifth power, we would do its reciprocal and then make the exponent positive. So that would become 1 to the n to the positive fifth power. P to the fourth power over 1 is already positive, so you leave it the same. And then 1 over r to the negative second power, you do the reciprocal, and you would have r to the positive second power over 1. Then just multiply across. 1 times p to the fourth times r to the second, and then n to the fifth times 1, and you get this right here. Okay? Now, I have only one of each base. All the exponents are positive, and no fraction needs to be simplified. So this is in simplest form. All right, let's look at it again. So in this one, I could break it up again. I would have 4 over 16. I would have a to the negative third power over a squared. And then I would have b to the sixth power over b to the sixth power. And I would have 1 over c to the negative fifth power. Okay, so let's break it down and see what we got here. 4 over 16, I could simplify down to 1/4. Then my a's, I can do it a couple of ways. 1, so let's do it over here. I could do a minus 3 minus 2 is going to give me a to the negative fifth, and the reciprocal of that would be 1 over a to the fifth. Okay? That's one way that I could do it. The other way is I could just do the reciprocal, and so a to the negative third power over a to the second power would be 1 over a to the second power, a to the third power, which would give me 1 over a to the fifth power. Okay? So either way would work. So that's 1 over a to the fifth power. B to the sixth over b to the sixth would give me 1, because that would be b to the 0 power, which is 1. And then I would do the reciprocal and have c to the fifth over 1. Now, I multiply those all across, and I get c to the fifth power over 4a to the fifth power. Okay? All right. Let's try this first one, and then you can do number 14 and come back and see how you did. So on the number 10, I have 3/7 to the negative second power. So I could say 3 to the negative second power over 7 to the negative second power. And then both of those are the reciprocal. So the reciprocal would be 7 squared over 3 squared. And that's going to give me 49 over 9, or 5 4/5. Okay? Now you try 14 and then come back and see how you did. All right, let's see how you did. So 8 over 4 would just become 2, and then c cubed over c to the negative 1 power would be c to the fourth, and then d squared over d squared would just be 1, and then f to the fourth over f to the negative third power would be f to the seventh power, so 2c to the fourth, f to the seventh. All right. Now this little part, just some information. Order of magnitude is used to compare measures and to estimate and perform rough calculations. The order of magnitude of a quantity is the number rounded to the nearest power of 10. For example, the power of 10 closest to 95 billion is 10 to the 11th power, or 100 billion. So the order of magnitude of 95 billion is 10 to the 11th power. So it's the closest power of 10. So I could use that in a problem. For example, it says, suppose the average height of a man is about 1.7 meters and the average height of an ant is 0.0008 meter. How many orders of magnitude as tall as an ant is a man? Well, we know that a man is 1.7 meters. So the power of 10 is closer to 1 than it is to 10. So we would say 10 to the 0 power, because that's 1. And then for an ant, we can round that up to 0.001, which would be 10 to the negative third power, okay? And then we just set up a ratio, 10 to the 0 power over 10 to the negative 3 power, which would give me, when I do my reciprocal, would be 10 to the third power, or 1,000. So therefore, a man is approximately 1,000 times as tall as an ant, or a man is 3 orders of magnitude as tall as an ant. Okay? All right. If you have any questions, let me know. Otherwise, have a great day.